Hello, everyone, and welcome. Thank you for joining us today. We are very pleased to see participants from different companies, teams, and locations joining our session. And today's webinar is dedicated to the new START-PROF 4.88 version and its latest enhancements. Before we begin, I would like to make sure that everything is working properly on the technical side. Please let me know in the chat if you can hear me well. And while we are waiting for your feedback, let me briefly cover a few points. Today's session will focus on the new key features and improvements introduced in the latest version, including the following ones: expanded and updated codes and standards, modeling and analysis enhancements, and improvements in reporting, integration, and overall productivity. During the webinar, we will also launch a few short polls to learn more about your background and experience. So we would really appreciate your participation. If you have any questions during the presentation, please feel free to submit them in the Q&A section. We will do our best to address them at the end of the session. And now it's my pleasure to introduce today's speaker, Dr. Alex Matveev, the head of START-PROF product development team. Alex, welcome.
Hello, everybody. So my name is Alex Matveev, and I'm product manager of START-PROF software. Today, I will tell you about the new features of the START-PROF pipe stress analysis software. This is the webinar agenda. First one is the latest code updates. Next, new features, smarter integrations. We will tell you about the new integration features like IFC format, PCF, stress ISO, and so on. And at the end of this webinar will be the exclusive bonus for our attenders. You'll get a free course on Udemy. It's a pipe stress analysis course, which lasts about 35 hours and have a lot of theory and can be useful for users of any pipe stress analysis software because it has a lot of theoretical information. Okay, so the first feature is the code updates in 2024. In version 4.87, we added, updated some codes. It is ASME B31E, 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 H12, and European codes for underground and above ground piping system, and also ghost code. And in next version 4.88 in 2025, we added new codes. It is the ASME B31E code for seismic analysis. Also, we added non-metallic piping codes. It's ASME NM.1 and NM.2. And we added the database with material properties from ASME NM.3.3 for non-metallic piping systems, and also added new GBT, Chinese gas and oil pipelines code, and updated the existing codes. It is the ASME B31E, B31E, B31H to the latest versions. Also, we updated the databases, material databases, updated allowable stresses, elastic modulus, Poisson ratio, and others in all codes we have in our database. And also we updated the European code to the latest version, updated the ASME B31J for stress intensification and flexibility factor calculation to the latest version, and updated the ASME B31G code for calculating remaining strength of corroded pipelines. Let's talk about ASME B31E. Now, in the latest version of pipe stress analysis software, we have an option. You can choose, for example, which allowable stresses we will use. It is sustained stress, or it is occasional stress. For example, standard occasional stress is 1.33 SH. alternative occasionals for high temperature piping systems according to ASME B31.3, and next ASME B31E. It is greater. It offer us greater allowable stresses. So if your piping system don't pass the standard occasion allowable, you can try to use ASME B31E, and maybe your piping system will pass the strength requirement using this code. Okay, so let's proceed. The next feature is ASME NM code for thermoplastic piping system. We added the database for thermoplastic piping materials. You now can see this database on your screen. It can contain Poisson ratio, contain thermal expansion factors, contain allowable stresses depending on the number of cycles and depending on the temperature. It contains elastic models depending on temperature and the load duration. So START-PROF automatically take required values from this database and use it during the stress analysis of the piping system. And we added all the materials from ASME NM.3.3, and you can choose them from the list. And also START-PROF can calculate the wall thickness of the thermoplastic piping, so you can define the diameter, temperature, some factors, choose material, define pressure, and receive the wall thickness, required wall thickness. Also, software calculate the stress intensification factors according to the rules of ASME NM1, and calculate stresses in the piping system. Let me show you the simple example of the piping system using ASME NM code. Firstly, let me show you how to calculate the wall thickness of the piping system. Let me show you ASME NM1. We choose which type of standards we use, okay, and this is the ASME NM, and here we have two elements. It's wall thickness of the pipe calculation and wall thickness of the band, meter band calculation. For example, I can define some diameter of the pipe, some temperature, erosion allowance, design factor, and choose the material. You see, this is the material list. I can choose, for example, polyethylene piping and set some pressure, for example. Calculate, and you receive the wall thickness, required wall thickness for this pipe. And let me create the real piping system, new piping. Now we choose the ASME NM1 code. You can set some options. You can define seismic, wind, snow loads, and so on. So everything the same as for steel piping system, ambient temperature. I will leave all default values, and now I will draw some simple piping system. I will add the pipe element. For example, it will be 2 meters. Outer diameter will be this one, and the wall thickness, for example, I don't know, maybe 9 millimeters, erosion allowance, and we choose some material, for example, this one. Choose pressure, temperature, for example, 40 degrees. I will not set fluid weight because the pipe will be too heavy, so I will leave 0 values. And also you can define some additional properties. It's design factors here. I will leave default values. So click OK. Now you can add the anchor in this point. And you can add the pipe in this point. Like this. So we have 2 pipes at anchor here. And I will put the band here. We have several bands available for this code. I will choose plain band. for example, radius 300, design factors, and nominal thickness. I will leave the same values as for straight pipe, and also you can see the stress intensification factors. So we have the following simple piping system. Let me save it. And now we can run analysis. So in output menu, we can receive the stresses in our piping. You can put your mouse over any cell and see the results of the equations, how that stresses was calculated. And of course, you receive the restraint load, displacement, everything. And let me show you the database. Database, material library. Each database in START-PROF is adopted for each standard. So for ASME NM1, we have the following database. It contains material properties. For example, right now the temperature in degrees of Celsius. Let me change units. I will change it to KSI and temperature in Fahrenheit. Okay. So now this is more beautiful. Its temperatures in Fahrenheit, allowable stresses according to the ASME NM.1, expansion factor, Poisson ratio. In this table, we have the allowable stress values depending on the temperature and depending on the number of cycles. And elastic modulus, it depends on temperature and load duration in hours. So START-PROF use this information to calculate your piping system, and load cases created automatically for this piping system. We can run analysis and see results. Okay. So next code is ASME NM2. So actually, let me return to ASME NM1. Actually, we have two codes for plastic piping analysis. We have ASME NM1 and we have DVS code. So you can choose which code to use for thermoplastic piping analysis. And ASME NM2, it's a code for FRP GRP piping analysis. We also added a special database with material properties which contain the allowable stresses, also called failure envelope in this code. And it contains the elastic modulus, axial elastic modulus, hoop elastic modulus, and shear modulus, depending on the temperature. This is the temperature, and also it depends on the wall thickness of the pipe. So START-PROF automatically take the wall thickness of the pipe or other elements and take specific values of elastic modulus for this wall thickness and temperature. And of course, you can calculate the wall thickness and or the wall thickness of the pipe and wall thickness of the bands for this code, like for all other codes. Of course, it calculates stresses and calculates stress intensification and flexibility factors. I also can show you. So let me close this example. Here in start elements, I will just switch to ASME NM2 and choose another material, FRP material. I will leave the same values, and let me check just a moment. Okay, I don't know what. Let me create again. I choose ASME NM2, ASME, and define the properties of the pipe. And choose the pipe material and the pressure, and calculate the wall thickness. So as you can see, this material can hold greater pressure values. And we can open the same file, which I already created, but I will change the code to ASME NM2. Let me show. I will switch to ASME NM2. And now I need to choose another material, so I will select all and switch material to FRP. And also I will change material for this band element. And also I need to define the properties. This is a wall thickness at extrudos, wall thickness at intrados, and we can check the properties of the pipe. It's diameter, wall thickness, same as for thermoplastic piping, same as for steel piping, but also you can define the protection layers, internal and external. And pressure and temperature, all other properties the same as for steel piping. Also, you can choose the layer type here. And you can run analysis. Also, load cases created automatically, so you can immediately check the stresses in this piping system. And you can check support loads, displacement, and all other output information. The next features we have, it's a new licensing system. We switched to new licensing, and now it supports the internet licenses. But of course, it's also also support the USB dongles, network dongles. It's for companies who don't have the internet connection. Also, we now support the Linux operating system. We tested it via Wine on different type of Linux systems. Also, we added the summary report table. Let me show you what is the summary report. I will close this file and open the example. Let me open an example. Okay. So, for example, we have some file with some nozzles, some springs, some pumps. This is the pump object. It automatically calculates the loads, check the allowable loads on this pump element, and have also the expansion joint. So we can open each table separately, but we also can open summary report. In summary report, we see the maximum stresses in our piping system is sustained stresses, its expansion stresses, and software show you in the ratio between calculated stress and allowable, and show you the pipe element or other element in which this maximum stress is detected. Also it shows the maximum expansion joint deformation. It is the ratio between the expansion joint deformation and allowable value, and show in which expansion joint exactly. And also it shows the flange leakage. If you have many flanges, it will show you the worst case, the worst flange. And also it shows you the nozzle and ratio between nozzle load and allowable loads, and show exactly in which nozzle. For example, if you have many nozzles, you will see which nozzle is loaded greater than others. And of course, you can print this table using the export to Microsoft Word export to Word or Excel. The next feature is that now we highlight the maximum stress ratio with yellow color in stress table, and we highlight the lifted supports which lift off. Let me show you. This is the stress table. You see this yellow, it is maximum ratio. And also this is maximum ratios between calculated stress and allowable stress. And in resting supports, we can see which support is left off this one. Also, we created the report to Microsoft Excel. Before this, we had a report to Microsoft Word using templates. Now we added a report to Microsoft Excel because some customers ask us because they need these Excel tables to check the model and use it for some automatic checks after START-PROF finish a job. So it is also available. I can show you. To do this, you need to use File, Export, Report to Microsoft Word, and choose here to Excel. I will not show you because it works the same like docx, but into Excel, and each table we put into separate sheet on Excel. And next feature is the detailed internal forces table. Sometimes we need to perform analysis using some pipe stress analysis code, which is absent, for example, in START-PROF. And to do this, we want to use Excel, but we have to take the information to that calculation. So we added this table, and you can perform the calculation of the stresses using any pipe stress analysis code using Excel. How to do this? You open Output, Internal Forces table, choose some specific load case, and choose here local extended. And now you see this extended table. In this table you have the axial force. It is true axial force and effective axial force in the pipe element. What is the true and effective axial force? I explain in my training course. So also you can find it in the help system of START-PROF. The next is the shear force to calculate, for example, shear forces, and also its torsion force, torsion moment. It allows you to calculate the shear stresses and also bending moments. It also allows you to calculate the bending stresses. And also it contains all required information to calculate stresses. It's the pressure, diameter, wall thickness, corrosion allowance, mil tolerance, material, elastic modulus at cold state, at hot state, allowable stress, yield stress, and some other properties. So you can use this table to calculate stresses in your piping system. Actually, it also print the values in several cross section on each elbow. For example, on this elbow, it shows 4 cross sections. For T elements, also it shows several cross sections. And also you can copy this table, copy entire table, then open Excel. Let me open Excel. And you just paste Ctrl V into Excel, and after that you can use this information to calculate stresses. Okay, next feature is enhanced spring selection algorithm for optimal spring sizing. We added new algorithm which works much better for nonlinear piping system with gaps, with single directional restraints, with friction. It can find more optimal springs for your piping system. Also, you can define weight for any supports in your piping system. any support in STAR-PROF object, and one of its properties is the weight. For example, if you have the pipe with some clamp, some support, and when this pipe lifts off from the support, for example, this part of support still acting on the pipe. It produces some weight load on your pipe. So we need to consider this load because it affects stresses on your piping system, the loads on the nozzle, for example. If you have nozzle here, it produces some additional bending moments. And we added this field for every support in STAR-PROF. It's up to you if you want to use it or not. You can just apply the weight to the support, and STAR-PROF will apply this weight to the node in which you place your support. And especially it is important for springs because some part of the spring are acting on your pipe and producing some weight, additional weight on your piping system. If you ignore it, especially for high diameters, you can receive incorrect springs and incorrect load distribution in the piping system. The next feature is real pipe length property. We added the special property, real pipe length. What is this? For example, we have this pipe and we have two lengths. One is distance between the nodes, between the points, cross-section points between the axes of the pipes. This is 0.h, and this is the real pipe length. This is the real length, 0.19. And you can change any of that length. For example, if I want to connect one band to other band, I will just specify 0 real length, click OK, and now two bands are connected. If I hide the bands, you will see the pipe, and the pipe length is equal to the sum of the radiuses of that bands. This is how we use this feature. The next feature is option to disable analysis of specific independent segments. For example, in your piping system, you have a lot of independent segments. For example, in this system, we have two segments. Let me show. This is the first segment, this one, and this is the second segment. But you can have 10 segments, 20 segments. And if you work with one segment, you don't want to analyze all of them because you don't want to spend the time. To do this, you can just switch off a calculation of some segments. How to do this? You can open any node, make it base node of the segment, and switch off this checkbox, analyze the segment. If you click OK, this part of piping will not be calculated. After you finish, you can open again it and click Analyze of this segment. After that, if you run analysis, STAR-PROF will calculate both segments. It also saves your time during working with your model. The next is disconnect function at the nodes. What is the disconnect? For example, we have this node and I want to move the equipment in this direction and make the loop like this. How to do this? I just click this node, right click, disconnect in the node. Now you see we have two node numbers here because we cut this pipe in this point. And now if I open the properties of this node and make this node a base node of the segment and change its coordinates to 0, for example, by y-axis, this part of piping will move here. So now we can just connect the two pipes, the two nodes with the pipe element. And it allows you to quickly change the layout of your piping system like this. I copied the band from this node here. Okay. Next feature is the two new coordinate system. I will not explain it in details. I will just show you that in any pipe element we have several coordinate system. The standard is projections. It's the x, the y, the z. But we have spherical coordinate system. You can define the length and angles. We have cylindrical, and we added two new coordinate system. If you like, you can investigate more, but I will just say that this system is very comfortable when you're working with long distance pipelines, cross city pipelines, for example, the pipelines between cities, because you have the pipe, you have the plan profile, so you can define the incline or the angle, slope angle. You can define the direction of the pipe, the angle, direction angle of the pipe from the x-axis or from the previous pipe. If you switch this option, the angle will be calculated from the previous pipe element. So it is convenient to work with long distance pipelines. And the next feature is single-use compensator. It's eComp, which is used for distributed networks. Now you can use this element with B31.1 code. Before this, it was allowed to use this expansion, single-use expansion joint eComp only for distributed networks code, but now we allow to use it for ASME B31.1 because some companies use this code for distributed network analysis. And also our users ask us to add the manual sieve specification for plastic piping codes. So now you can use automatic calculation or you can specify it manually. Up to you in both codes, in DVS code and in ASME NM1. And in the 2025 version, we allowed to apply the loads to the underground pipelines because some companies want to define search effects for underground piping systems. Also, we added the corrosion database, which contain the corrosion rates. I can show you database corrosion. And here you can calculate, you can take the corrosion rate from this database. You just put the name of the fluid you have and choose the material, and you can find which corrosion rate you will have. Okay, and you can use it to calculate the corrosion allowance. For example, if you open the pipe properties, here is the corrosion allowance. You click here and you can choose, for example, water, find the corrosion rate for water, and you can choose any value, double click it, and START-PROF will multiply the corrosion rate by the service life in years, and you receive the corrosion allowance value. For example, right now we have 20 years multiplied by 0.1 and we receive 2 millimeters. And corrosion allowance used to check this pipe for pressure load. And in some codes, not in all codes, but in some codes, the corrosion allowance also affects stresses in your piping system, but in most code not. And the next is the support database. It contains the weight of the support dimensions. It contains the allowable loads and also friction factor. Let me show you databases, restraints here. This is the support database. We update this database in each version. For example, I choose this one. It is Lisega database. And you can see the weight of this restraint. You can find the allowable loads and the restraints. Is it resting support, fixed anchor, and so on. So you can choose which restraint we have in this support. And the code description of this support according to the manufacturer catalog. So, for example, if I want to choose the rest and support from this database, I click here. I choose some catalog, for example, the Sega. For example, I will take this one. Double click, and you now see we have weight, friction factor, and allowable loads. And also in new version, we added ability to define individual allowable loads for each operation mode, for each load case. So, for example, if your piping is working with different temperatures, for each temperature you can define own allowable loads. Also, if you have some occasional load cases, you can define higher allowable loads for occasional cases. And for example, you can switch off the load checks for seismic loads. For example, you can switch off the allowable load check if you want. So now you can change it. And also you can use the load multiplier. For example, allowable loads on the supports depends on the temperature. And here you can define this multiplier depending on the temperature for each operating mode. Right now we have two operating modes, operating and emergency. But for example, you can have 50 operating modes, and you can define the multiplier for all operation modes. The next feature is that many users asking us to add for several years. Now finally we added. They asked us to make the z-axis vertical and y-axis horizontal. Y-axis vertical and z-axis horizontal, and also ask us to add the north direction. And in this version we added this feature, so you can open the project settings and switch this option. Y-axis is vertical, and also you can go to other north direction and define some direction of north axis, for example 30 degrees. And now you see the north direction, and now y-axis is vertical. Let me switch off this feature. Okay, now next feature is that we added the stress intensification specification for flange pairs. Before this, if you want to consider the stress intensification in flanges, you have to add the special joint element. For example, let me put it here, the joint element. And here you need to define the type of connection and define the stress intensification factor. But now we added that properties to the flange pair object, and now you can just choose the type of the flange, and START-PROF will consider the stress intensification factors for this flange. And also you can choose other and type the values manually if you want. Next feature is allowable load specification for steel structures. What does it mean? For steel structures to which the spring hanger is connected. For example, this spring hanger is connected to some steel structure, and the allowable load on this steel structure is just 1,000 kilograms, for example, but the allowable load for this spring is 2,000 kilograms. But if we select the spring for 2,000 kilograms, the load on our steel structure will be failed. So to avoid this, we added the checkbox, and here you can define the additional allowable loads for a steel structure to which this spring is connected. And also we added a new soil model according to the EN code, European code. This is the longitudinal spring properties and horizontal spring properties. We plan to add several more soil models So you can choose which model to use. And actually, all that models will use the same database. Right now, all START-PROF soil models use the single soil database in which you have the properties of the soil, and it uses that properties to calculate the soil springs and automatically put the soil springs over your model. And next feature is that the connected element temperature calculation. For example, if you have a pipe with tranion element, for example, you have tranion like this, and you need to define temperature. For example, temperature in your piping system is 200 degrees, but which temperature we need to use for the tranion element? Is it 50 degrees or maybe 100 degrees or maybe 20 degrees? Which value? So this calculation allows you to answer this question. Let me show you. I create new elements, start elements, and choose here vessels and equipment. Okay, and this is the calculation of the connected elements temperature. For example, temperature of our piping is 200, the ambient temperature 20, and height is, for example, 1 meter, shell wall thickness 14, and no insulation. I calculate and I receive 58 degrees. For example, if our support is very long, for example, 10 meters, our temperature is almost close to the ambient temperature. If the height of this element is very small, like this, the temperature is very close to the main temperature of the pipe. And of course, it's also affected by the wall thickness and insulation. So you can quickly calculate this value. And next feature is the flexibility analysis, which allows you to answer the question if the stress analysis required or not for our piping system. How this is working? Let me show you. I choose ASME B31E-2008, for example, and I choose this check necessity of stress analysis. And you define pipe diameter, operating temperature, ambient temperature, developed length, for example, 35 meters, and straight distance between supports, this is U, 30 meters, and choose the material and run, and the condition is failed. So this system requires stress analysis. But if I increase the length between anchors, for example, 50 meters, then the condition is satisfied and we don't need to perform stress analysis. But of course, this is not only condition which answer the question if we need stress analysis or not. There are a lot of other conditions, but this is one of them. And this is the most complex because you need to perform some calculations, and we simplified this job for you. And also the new features, it's selection. You can select all underground piping or select all above ground piping, select current segment, invert selection, and edit selection. Let me show you. Actually, this is very interesting feature. For example, I can select some part of piping and I want to select the bands, but only for this part of piping. I don't want to select that bands, only that bands. How to do this? I select the part of piping, then edit selection, clear selection, and select only elbows and click OK. Now you see only elbows are selected, and I can change the radius of that elbows like this. And the same way you can change the, you can select the supports. For example, I select this part of piping, edit selection, and select variable spring hanger and rest and support. Okay, and now you can push delete button and delete them, for example. So it's very important feature. And next is the past nozzle FEM nozzle stress calculation. Links also added into Microsoft Word reports, and we added a special button which show you the finite element calculation of any element. For example, we have the following piping system. We have a nozzle here in which we select the nozzle FEM to calculate the stresses in your piping system. For example, if I select the nozzle flexibility calculation, nozzle FEM will calculate the flexibilities of the nozzle. But also after analysis, START-PROF transfer loads from your piping system into nozzle FEM software, and it allows you to calculate stresses. So let me do this. I will run analysis. Don't recalculate. And before this feature, you had to open the nozzle FEM software as separate software, separate application, and then open the reports which generated by the START-PROF in special folder, and open that reports in nozzle FEM software. But now you don't need to do this. You just open the stress table and click the button. Let me show you. Oh, sorry, not stress, the table nozzle and equipment loads. You choose some specific condition, operating condition, for example, and we have the button here. You just click this button and the table is opened in the separate window, and you can check the stresses and see the finite element model of your nozzle. And next feature is the complete bill of materials. We export it now to Microsoft Excel. Before this, we exported to HTML format. Now we can export to Excel. Service, create list of piping elements, and here you can select Excel. So you will receive the bill of materials. You will receive how many bands, how many pipes, how many supports you have in your piping system. Next is all databases of pipes, fittings have been updated according to all standards. We have databases for pipes, bands, tees, reducers, flanges, single flanges, gaskets, valves, beam elements. So all that database was updated to the latest versions of the standards. Actually, this was the great job. And we added node number filter. It allows you to select which of the objects, the node numbers at which objects you want to see. For example, I want to see the node numbers only at the supports. You select this option, and you see node numbers only at the support. You can select hangers. In this case, you will see it only at hangers. START-PROF users asked for this feature, and we added. The next is seismic wave propagation calculation for buried piping. Now we added two type of waves calculation for compressive and tensile waves. We put it in two directions because due to pressure load, temperature load, we can't know which will be the worst case in advance. So we check both type of waves now. And we added now the flexible element deformation. We display in expansion joint table. Before this, in this expansion joint table, we show only node node expansion joint, but now if you use flexible element, it's two node expansion joint. Now you can how to say, you can see the deformations of this element in the expansion joint deformation table. And next feature, let me check, next feature is the batch fitting insertion for empty nodes. Let me show you, sorry, let me show you this feature. Actually, we have integration with a lot of CAD software, and sometimes when you import from some CAD software, you don't have any fittings. For example, when you import from Excel, you receive your puppet model, but there is no bands, no T elements like this. You see, there is no bands, no T elements, and we need to insert them. Before this, people have to insert them manually, but now we added a special feature. You go here, edit, select empty nodes, and it automatically select the nodes in which we need to insert the bands, teeth, reducers. I will choose only bands, this one. But if you have several diameters, you will have different rows in this table for each diameter separately. So right now we have only one diameter. I click OK, and now you see all the nodes, node numbers are selected. So now I can just insert the band. OK, and the bands are inserted in each node which was selected, you see. And the same way we can select, for example, nodes to insert T elements. Select empty nodes, select, for example, T elements, okay? And you see this node is selected, so I can choose the T element. And if you have several such nodes, it will be inserted for into all that nodes.
It's time to move to the next part of our webinar, which is dedicated to new capabilities of START-PROF and integration solutions. And I would like to invite Nick Maximenko, the head of CAD department. Nick, welcome.
Okay, hello everyone. I am Nick, and at PAS team, I am responsible for developing integration solutions between PAS software and other CAD systems. During this section, I will be assisting Alex Matveyev and showing several of our latest developments. So first of all, I want to say that START-PROF is integrated with many systems and formats. This slide shows the main integration direction. First of all, PAS START-PROF is integrated with our other software like PAS Hydro System and PAS Nozzle FEM. Also, START-PROF is integrated with Autodesk products such as Autodesk Revit, Autodesk Civil 3D, and also AutoCAD. With AVEVA, we have a two-way integration with model synchronization. Using IFC or PCF format, integration is possible with any systems that support these formats. Also, we have integration with CISA 2 and Microsoft Excel. And also we can export DXF files and open them in AutoCAD. And if you have a special or complex task, any integration can be implemented using the API interface using .NET or C#. So recently we have paid a lot of attention to the tool for generating isometric drawings. We completely redesigned it, and in addition to AutoCAD support, added support for BricsCAD. I will show examples of how this look like a little bit later. We also added support for Spanish and Chinese languages and introduced automatic installation. So now you don't need to manually place files into the folders. Everything regarding installation is done automatically. So in Start AVEVA, we have many architectural and logical improvements. The main enhancement is that the model now supports transferring of AVEVA MDS, so it means multidiscipline supports, and it includes ANSI and TRANSI attachments. We also introduced a large number of improvements to PCF interfaces. From my opinion, at the moment, the import module is one of the best on the market, and we regularly add support for specific systems. For example, we added support for PCF generated from Autodesk Inventor. So in the Caesar modules, we added support for the latest Caesar versions, for example, 14 and 15, as well as full support for most ASME codes. You can see them on the screen. These codes like ASME B31E, B31E, and other ones. In the latest version, we added the ability to import and export IFC files. It's a de facto standard by Building Smart, and it allows START-PROF to integrate with dozens of different information systems. So let's take a look how this works in practice. I will launch the START-PROF. And open the sample model. Okay. So as I mentioned earlier, one of the most useful and widely used developments is the model for generating isometric drawings from START-PROF model. Initially, the model was developed for AutoCAD, but due to high demand, it was also ported to BricsCAD. So to export model, we just need to click Export and select to stress Ether 3D. So as you can see, there are possibility to export to AutoCAD and BricsCAD, and you can choose the version of the platform. So after pressing the button, the selected platform starts automatically. So, and the solid model is generated. So the model contains a full set of data, and we can place them on the isometric drawing sheet. Let's see. We will create custom viewport like this. We will adjust the scale. Okay. And then we can make annotations. I will select restraint tags and dimension lines. Okay. And we click Auto button and select our viewport. Everything is done. As you can see, the dimension lines, the tags are placed automatically. Also, you can automatically place the tables, for example, piping input data. So this data comes from the past START-PROF model. And some other table, like, for example, selected springs. And other tables, for example, stress summary report. So all the data are transferred automatically. So in the bottom of the sheet, you can see the legend of the anchors. So this is a very useful tool for generating isometric drawings. And if you have suggestions how to improve it, we are always open to ideas. Next, I want to show the IFC export and import module. We already have this model in START-PROF. To make the IFC export, you just need to click Export to File IFC. Specify the path and select the export type. There is a possibility to export the cut type or vertex type. I will select cut type and just click export. File was created, and now you can open this IFC file in any software that allows you to load these files. So this is our file. So this is not only 3D model, but it also contains all process data, for example, for pipes, bends, etc. Also, you can import IFC files to START-PROF. I will open file here. So let's see. As you can see, it was produced from Aviva. To import files to START-PROF, you just need to select file, import from IFC. You just need to select this file and select import profile and just click import. So as you can see, this is completely the same models. So I hope this overview helped you understand our software better. And if you have more questions or need help, we are always here. Happy to keep supporting your projects.
Thank you, Alex and Nick, for your presentation. And thank you everyone who joining us today. And we hope this session has given you a useful overview of the new capabilities introduced in START-PROF version 4.88. Many thanks again to our speakers, Alex and Nick, for the presentation, and to all participants for your time, attention, and active participation. If you have any additional questions after the webinar, please feel free to contact us. Thank you once again, and we wish you a great day.